welcome back to Beyond Pipelines. In today's lecture, we are going to talk about types of pipelines related to oil and gas exploration fields and the export lines. A typical oil and gas field is explored in very large area. It could be 50 square kilometers or 100 square kilometers. It's that large. And number of wells depend on the extent of that field. The number of wells could vary from 10 to 50 to 100, to tap the entire hydrocarbon available in the field. So there will be multiple wells drilled across the area, and then those wells are drilled in a different stages. Initially there will be few wells drilled to check the performance of the field, and then once the performance is proven, then the field will be further explored. So the early initial wells will be called as normally the early production scheme, EPS, and then based on that performance, it will be field will be further developed. The investment will be increased, so number of wells may increase per stage. The crude oil from these wells will be transported by means of the pipelines and flow lines to the facility, the treatment facility, from which the further export can take place. Multiple manifold option is normally considered, because imagine that it's a large field where hundreds of wells are going to be drilled, and they are to be connected by individual flow lines to the station treatment facility. So all the individual flow lines, which are basically transmitting the fluid from the wells, cannot be of that long length. So to make the hydraulically suitable design, multiple remote manifolds are normally built, to which the individual well flow lines are connected, and then further it will be larger diameter pipelines will be connected further. So it becomes kind of a network of flow lines and larger pipelines and further larger bulk lines, and like that, all the way up to the treatment facility. So we will see a typical exploration field pipeline network diagram now, which is called schematic. And then in that schematic, I have explained all the types of lines in which we are going to talk about. There are different names given to these lines, because depending upon their connection to well or the manifold or to the facility, accordingly they will be carrying the volume of fluids, and their names are related to that. Also, their criticality is also related to how much volume the line is going to carry or transport. The more the volume, it becomes more critical, because obviously any disruption in that pipeline, which is carrying a larger volume or larger inventory, it is typically called in oil and gas industry, will have the repercussions, economical repercussions as well as environmental impact. So the more the volume the line is going to carry, the more inventory it is going to lock, the more critical it becomes, and accordingly the design features are selected based on that, which will come in the further future series of lectures. But at the moment we are only going to see what are the types of lines and how they are described in that fashion. So this is a typical oil and gas field development schematic, which is also called off-plot schematic in the oil and gas world, which has got, I've numbered them from 1 to 8, and I'm going to explain you one by one what exactly it is. So try to just understand that from the well to the remote manifold to the central gathering manifold to the processing plant is how the network is going to look like. Now let us see one by one what exactly is the meaning of these lines, and what is going to happen. So first, number one was oil and gas well. Now crude oil or natural gas well, this network diagram remains almost similar. So I'm not going to take separately for the crude oil and natural gas. Assume that if the well is crude oil well, then the lines will be carrying the crude oil. If the well is related to natural gas, then the lines will be carrying natural gas. So this is a typical oil and gas exploration well drilled in the field, and then that will bring the hydrocarbon fluids from the subsurface downhole half a kilometer to 2 kilometer, 3 kilometer down to the surface, from where we need to connect it with the flow line or pipeline to the main to collect it together to the treatment facility and for the export. So flow line is connecting the line from one particular well to manifold, remote gathering manifold. As I explained to you, remote gathering manifold becomes important because you need to keep the flow line length minimum. You don't want very long flow line lengths because its diameter is also smaller because it's carrying only fluid from one well. So hydraulically and economically, there is no point in increasing the diameter of each flow line and making it very long, and therefore we normally consider multiple manifolds, remote manifolds, or they are called satellite manifolds, to which the flow lines are connected. So the flow line lengths are normally kept within 3 to 5 kilometers. Then comes the remote manifold station, which is called RMS, RGMS, or satellite manifold, which are basically provided in the field in such a way that they are surrounded by 8 to 10 wells, so that the 3 to 5 kilometer flow line lengths will be connected from individual well to this manifold. Then there will be trunk line, which is connecting the bulk of the fluids coming from the 8 to 10 wells which are connected to the remote manifold station, which is taken together in a trunk line to the either central processing facility, or if the area of the field is not much, then number of wells are less, then it will be connecting directly to the main processing facility. So this is going to be called as trunk line, which is going to have the fluid collected together from multiple wells surrounded by the manifold. Then there will be central gathering station. As I said, if the field is very large and if there are hundreds of wells, then you can't have a single remote manifold station and then 100 flow lines connecting it to that, because then once again the length of individual flow line will become very long, which is not going to be economically and hydraulically practical. So there will be multiple, imagine there will be something like 10 remote manifold stations, and that's why they are called satellite stations, distributed in the oil and gas field, entire area, to which the individual flow lines will be connected, and from there the trunk lines will be taken out to the central gathering station. In central gathering station, all the trunk lines will come together. It can be multiple central gathering stations as well, depending upon the area and geography of the overall plot. So the trunk lines will be going out from the satellite manifold and connecting to the central gathering facility, where once again it's a larger manifold, larger diameter manifold, from where all the fluids from the multiple satellite manifolds are collected together. Then there will be a pipeline or bulk line. Okay, as name suggests, now this is going to start from the central gathering station, where all the satellite manifolds have brought the fluid together, and it's going to carry the bulk of the fluid from multiple satellite manifolds, which are basically taking the crude from the multiple wells. So it is going to carry multiple number of well fluids all together as a bulk. So it is also called bulk line or a pipeline, and it is going to connect from the central gathering facility to the main station. And obviously it is going to carry large inventory, and line becomes very critical. Some new very important concept is called loop line, which is nothing but a bulk line or a pipeline. What it does is it's normally installed in parallel to the bulk line between the central gathering station to the main station. Why it is important is because when you are developing a field, initially you may not, it's all unpredictable, yeah, because it is subsurface thing, and then you don't have the accurate results. You can't see it by your eyes. So whatever is happening is based on the engineering judgment of the subsurface team, and there are various tests conducted from the surface, and they are going to drill the wells initially with fewer numbers, and if the performance of those wells are found to be good as per the original anticipation, then they will go on further increasing the drill the wells and increasing the capacity and tap the complete hydrocarbon volume of that particular field. So what happens in the pipeline capacity perspective, that initially there will be lesser flow taking place from the bulk line as the number of wells are going to be less. Then there will be increased number of wells, so the flow is going to increase, and then once again as the life goes further, the number of years are going to take place, then the fluid, the flow rate might go down because some of the older wells might be depleting, and then they are producing less and less. So in the design lifetime of the pipeline, its capacity is like, initially it's going to flow less than its design capacity. Then it's going to flow for some period of time, it's going to flow to the full of its design capacity or slightly higher sometimes. And then later years, once again it can go reduce, it will be reduced to the again lower capacity based on the depleting well performance. So it is always considered, and there is one very important concept, like flow rate. If the line is flowing sufficiently full, then the corrosion initiation doesn't take place in the pipeline. They are normally carbon steel pipelines which needs to be regularly picked and maintained, and chemical inhibition is done for to maintain its design life and extend the life further. So when the flow rate line is not flowing full and it is running with very low velocity, then the separation of liquid is going to happen, temperature drop is going to take place, and because of that the water can get, stagnant water can get deposited at the low points in the pipeline, which can initiate the corrosion reaction. So basically what happens is, in order to make sure that throughout the design life sufficient flow rate or velocity of the fluid is achieved in the pipeline, so that its corrosion is kept under control and its corrosion prediction, pigging and maintenance becomes relatively practical. To achieve that, many times a loop line concept is designed by the hydraulics people, or that is normally done by the process team in conjunction with in discussion with the corrosion team and the pipeline team. So what is going to happen is, if you want a larger diameter pipeline for the maximum flow rate of the field, which is only periodic, then instead of designing and installing a larger diameter single pipeline, you divide it into two and then you install two pipelines. Now these two pipelines can be installed from day one if your flow rate is going to be on the higher side from the beginning. But normally that is not the case, because wells are going to be drilled in sequence, and based on the well performance, then you are going to increase number of wells and the flow rate is going to increase. So this helps you in dividing your capex investment also, because initially you invest only for single line, and then as the flow is getting proven, assurance is coming from the field, and more number of wells are being drilled, then you after a few years, say 5-6 years down the line, you add one more line which will be called as a loop line, and with two lines you take the flow, and then eventually when the flow rate is going to go down in the later years of the field life, then you can decommission one of the lines, can be older line which was commissioned first, and then mothball it, fill it with nitrogen and keep it if it has got the design life available in that. Keep it for some future development, or if you want some quick turnaround for some other nearby fields, then you can utilize that. But by doing this, you can keep the corrosion under control, maintenance, to maintain its design life within the practical limits. So this is the concept of the loop line. So it's nothing but a pipeline bulk line which is carrying multiple fluids but divided into two parts to divide the capex investment and also to take care of the flow rate fluctuations. Also, if there is any turn down required, then also it helps. So loop line is very important concept use in many oil and gas exploration cases. Now we'll see 8 is the processing facility which is basically getting all this crude oil or natural gas, and it is removing the impurities and then making it suitable for the export quality. Conditioning is done, and then it is making it suitable for the export facility so that the export lines can then take the crude further to the export terminals or distribution to the various locations required. Then comes the export pipelines, because now we have reached from the well by means of trunk line, bulk lines, loop lines, all the way to the treatment facility, processing facility, and from there now we have done the separation, we have done all this conditioning, and now starts the export pipelines from there. So if it is crude oil, then there will be pumps, and then the crude oil will be transported from these by means of export pipeline to the desired terminal location, tank farm or some kind of industrial area where you need to supply that crude, or to the seaport tank farm where the crude will be stored there, and from there it will be exported by means of ships for the export of the country, basically. Crude oil tank farm, as the name suggests, it's basically gathering all the crude together in the tank farm. It's also sometimes called strategic storage, because you can keep a large amount of crude oil stored there, and if there is a anticipated fluctuation in the oil price, then sometimes you can increase the export whenever required, depending upon the higher price available in the market. But for the large producer, it doesn't really matter. They can average out, and then it's a continuous export. So huge tank farms are normally built, and which are storing this crude coming from the various processing plants of the oil and gas exploration fields, all along the country. Then there is something called crude oil transfer pipelines to shipping terminals. So what happens is the tank farms which are near the seaport, from there the lines are installed to the transport jetty where the loading arms are there, and then the ships are going to come and get anchored near the jetty, and then ships will be loaded with the crude. If the jetty is not possible, if the depth of the sea is not much near the shore, then the ships need to be anchored deeper inside the sea. They cannot come close to the shore. In that case, the subsea or buried pipeline is installed from the tank farm to the something called floating buoys, where the lines are connected, and from the buoy, near the buoy, the ship is anchored, and then when ship is anchored there, then from the terminal, the launch will go. They will connect the hose from the buoy to the ship, and then that's how the ship will get loaded. I have also given here one picture about how it's going to look like, the buoy and the connection of the pipeline to the buoy, and then hose connection from the buoy to the ship, which will explain all these things to you better. Then there is something called gas export pipeline, we just talked about the crude oil and export to the ship, but gas export pipeline is basically the treated natural gas which is required in the country itself for the various power plants and industries, and then gas cannot be straight away exported, so it has to be converted to the liquefied natural gas, LNG, to reduce its volume, and in the high pressure liquid form, then it is exported also by means of the vessels, ships having spheres, some specific type of vessels are required to do that. So gas distribution is required for catering to the country's power plant needs plus industrial needs, and also it supplies the gas to the LNG facilities where the LNG is made for the export. So this becomes part and parcel of every country's the economical cycle, the gas export network, which is explained in the slide. Nothing. This is gas distribution network, which is same as export network, but gas distribution is taking basically the export to the various local use plus the export. So it is also called the grid or distribution network. Like electricity overhead grids are installed along the country. These pipelines, gas pipelines, are installed buried across the country, but people normally, common man, don't see them and they don't understand. But actually, it's like a electrical grid. It's called pipeline gas grid, and it has got high pressure, high capacity of the gas field in these lines. And then wherever is your requirement, it will be distributed by providing a connection from this main grid pipeline to the local use. So I will show you in the next slide about that. So basically I'm trying to explain you about what are going to be the different types of pipelines in the oil and gas industry, so that it becomes easier that what kind of projects are going to come and how you are going to design it, and depending upon its volume and capacities, how the criticality is going to vary. So all that is important when we enter the design part in detail about the codes and standards and actual design calculations and what are the design factors involved. So this gives you the background about oil and gas field development and the pipelines, type of pipelines basically. So this is a natural gas production and distribution network diagram, okay, which is having the production and processing facility, basically wells and the flow lines, which I already explained to you. The same way it is shown, the gathering systems, then the treatment facility, and then it has also got some kind of a liquid part in the gas, which is also having energy value, so which is then taken to the crude oil system for the export. The gas is then treated gas is then further distributed by the means of transmission, and being gas, it requires the larger diameter of the pipeline because it is having larger volumes, and then it requires sometimes the booster compressor station. So these lines could be like across the entire country, so they could be like 500,000 kilometer long distribution network. So intermittent, instead of sending very high pressure gas all the way, so that when the 1,000 kilometer away destination requires certain pressure, instead of doing that, intermediate gas booster stations are normally installed, so that when the pressure drops to certain value, then it will be boosted further, and then further it will transmit. This helps in making it more economical instead of making the whole pipeline of very high pressure. So this is it shows the transmission and storage with the compressor stations. Booster stations are basically compressors because gas requires compression to increase the pressure and transmit further. Then there are some underground storage, strategic storages, where you can temporarily store the gas and then use it when there is any emergency, some uncertainties, then that can be utilized. Distribution is taking place further by means of again distribution network. It will go to city area where you need multiple power plants. Then you need large customers like major industrial complexes requiring gas for various their use plus the power plants of the industry itself. Then there will be residential customers in the city where the large gas power plants will be there, and then it is producing the electricity and distributing it to the cities. And then the commercial customers will be there like LNG, where you convert that into LNG and then you export the LNG. So this is the typical gas production and distribution network, which I already explained to you in the lecture before. Now let us see quickly about the storage tank farm and the export ship, some picture, which will just to give you a good idea about how it's going to look like. So export across the countries takes place normally by the sea. As I told you earlier, sea is one of the very important transportation type method used when you have to export the crude across the countries, where the sometimes pipeline cannot be built because of the very long length and geographically very far away located countries. Near the sea terminal, the tank farm will be built, to which the export crude pipelines will bring the crude by pumping, and large diameter pipelines called main oil lines or main oil pipelines from the, or bulk lines from the main all the processing facilities in the oil and gas exploration fields all the way to the tank farm, where from where the export by means of ship is going to take place. So I will show you this typical picture where this shows the tank farm on the right top picture, and then a typical ship which is anchored deep inside the sea, and there is a floating buoy to which the subsea pipeline is connected from the tank farm to that buoy, and from that buoy a hose connection is provided to the anchored ship to load the crude in the ship. So there is a top view also which shows the buoy, and then from the terminal jetty the launch goes for the authorized team, and then they connect the hose to the ship, and then there are meters to measure how much crude is being shipped, being exported. And then I've shown one typical green color, the oil carrier, this is how the ship looks typically. It has got large oil tanker storage area below the deck. So this is how the ship looks. So hope you have understood by this the types of flow lines and pipelines and export network of various crude oil as well as natural gas. This I'm sure will help you to understand the overall oil and gas business, and then we are going to actually design these pipelines and flow lines in detail. I'm going to tell you about how the codes and standards are used and these lines are designed. Any pipeline or flow line, basically the design remains same. As I said, only depending upon its inventory, the criticality aspect changes, accordingly design factor changes, and the importance given to that, and then the precautions taken, measures taken for that changes. So which will come in the further series of these lectures in the various topics, under various topics it will be covered. So I hope this gives you a very good idea, and hope you are enjoying this series.